Decision tree model using the same metrics using consistent evaluation methods allows fair comparison between models. The decision tree shows improved flexibility compared to logistic regression, but many suffer from overfitting. This is reflected in differences between training behavior and test performance. In this cell, I plot the ROC curve for both logistic regression and decision tree models. By comparing the curves and their IUC values, we can determine which model has better overall discriminatory power. Yes, and here is the curve for logistic regression and decision tree. In summary, both baseline models provide useful insights, but show clear limitations, especially regarding a class imbalance. These results justify the use of advanced models and techniques such as SMOTE in later stages of the project. Random forest with SMOTE. Best performance in terms of recall and RUC and IUC for the default class. Random forest was combined with a SMOTE to address a class imbalance and improve the detection of the default customers. This model is able to capture nonlinear relationship present in the data. Whereas here is a SMOTE application, we will have a SMOTE application and a nonlinear modeling. Here, why random forest work well? Handles nonlinear patterns naturally, robust the outliers and noise, captures features interactions automatically, resistant to overfitting through assembling. SMOTE and random forest model. In this notebook, we implement a random forest classifier combined with SMOTE for handling class imbalance. The main objective is to improve detection of the minority class, which represents defaulting customers while maintaining good overall generalization performance. Here I import the necessary libraries. Pandas and NumPy are used for the data manipulation. From skitlearn, I import random forest and evaluation metrics such as confusion matrix and RUC curve. From imbalance learn, I import SMOTE and pipeline to correctly integrate oversampling into the training process. Matplotlib and Seaborn are used for visualization. Here I apply future scaling using a standard scalar. Scaling is important for distance-based operations with SMOTE and for stable model training. This cell defines a machine learning pipeline that combines SMOTE and random forest. SMOTE is applied only the training data to generate synthetic samples of the minority class. The random forest model is then trained on the balanced dataset. Using a pipeline prevents data leakage and ensures correct workflow order. And this is the confusion matrix. Here I visualize the confusion matrix for random forest model. The heat map clearly shows how predictions are distributed between default and non-default classes. RUC curve explanation. This plot in this cell I plot the RUC curve for the random forest model. This curve shaped and UC value indicate a strong discriminatory power compared to baseline model. In summary, applying a SMOTE significantly improves the model's ability to detect default customers. Random forest combined with SMOTE provides a strong balance between performance, robustness, and generalization, making it solid candidate for this problem. Yes. Neural network MLP model. A multi-layer perceptron MLP was used to model nonlinear relationships between features. The model was trained on scale data and outputs the probability of default. Here is three main things: input layer, hidden layers, and output layer. In this notebook, we implement a neural network model using a multi-layer perceptron or MLP. The objective is to explore a knowledge-based approach for a credit default prediction without using a deep, overly complex architectures. Here is the required libraries. And here I define the MLP classifier. The architecture consists of a limited number of hidden layers and neurios to avoid overfitting. The model uses standard activation function and it's trained using a backpropagation. And here I generate prediction and predicate probabilities on the test set, predicating probabilities as required for RUC and EUC evaluation. And here is the classification report for RUC and EUC. In this cell, I evaluate the neural network using a classification report, and RUC EUC score. This matrix show how well the model identifies defaults compared to non-defaults. And here the confusion matrix. And here the this markdown cell introduce the RUC curve for the MLP model, and in this cell I plot the IOC curve for the neural network. The curve is shaped and UC value indicate modern performance compared to ensemble models. As you see here, the curve. Yeah. In summary, the MLP captures nonlinear patterns in the data, and it performs better than simple linear model. The model comparison. Yes, in this project, multiple supervised learning models were evaluated to compare the performance. Yes, and we will compare between baseline and logistic regression, random forest, and neural network. In this notebook, we compare and evaluate all previously trained models. The goal is to objectively assess their performance and select the most suitable model for credit default prediction. Here is the required libraries, loading the data, and the test, train, and splitting the data. Here is the scaling, and here is the evaluation, logistic regression evaluation. Here I evaluate the logistic regression model, and here I evaluate the decision tree classification classifier model. Also here the random forest plus SMOTE evaluation. Yeah, and yeah, exactly. Yeah. In this table, I summarizes the performance of the all evaluated models. We compare recall F1 score and RUC EUC to understand each model's ability to correctly identify defaulters and balance precisions and recall. So RUC curve comparison RUC curves are plotted to visually compare the discriminative performance of all models across different classification thresholds. Yeah. In this cell, I plot the RUC curves for all models, and on the same graph, these visualizations allow direct comparison of their overall classification power. And here, as we see here in this graph, the RUC curves show that the random forest, which is here the green, the random forest model consistently dominates the others. This indicates stronger separation between default and non-default classes and better handling of the data imbalance. Based on the evaluation matrix and RUC analysis, the random forest model with the SMOTE is selected as the final model. It achieved the best balance between recall F1 score and overall robustness. Yes. Credit card default prediction is supervised and unbalanced classification problem. Multiple models were evaluated using appropriate metrics such as recall and RUC-EUC. Random forest with a SMOTE provide the best balance between performance and interpretability. Accuracy alone is not sufficient. And yeah, this is right. Accuracy alone is not sufficient for evaluating credit card risk models.